All right, so here we have a quick review of function notation. Now, function notation is where you have this fancy looking thing here. Now, this is not f times x. Not f times x. Oh, by the way, you should not be multitasking during these. So please put your phone away, turn it over, and just, be present. Be present and be watching this, okay? So this is pronounced f of x. F of x. It does not mean f times x. It's a fancy notation that basically tells you a couple things. It means you have a function, and functions are always one-to-one, and we'll talk more about that here in a second. Function notation also tells you the input variable. So that tells us that this spot right here is where we're going to be putting numbers in. This should sound vaguely familiar from Algebra 2 and Algebra 1. All right, so I've given you a function. F of x is 3x minus 1. So I'm going to come down here and let's find f of 2. F of 2. So that's a fancy way of saying, hey, substitute x equals 2 and put it in right here. Put it in right there. So that would be 3 times, okay, so that's what my machine, I like to think of functions as machines where you shove numbers in and numbers just pop out. So we're going to shove a number in here. We're going to shove x equals 2 into this, and that would be 3 times 2 is 6. 6 minus 1 is 5. So hopefully this is sounding familiar and easy. So I would like you just real quickly figure out what f of negative 1 is and put your answer in the chat. And while you're doing that, I will do a quick attendance here to see who is participating. All right, very good. It looks like -4, so let's check those answers. The machine is 3 times the input minus 1, and this time we're putting -1 in there. So that would be -3 minus 1 equals -4. -4. Two negatives don't make a positive in this case because it's -3 and then -1. We got 4 negative Nellies here all together in the same room. Very good. All right, let's move on. Another advantage of function notation is that you can actually talk about several functions all within the same problem. So when it comes to word problems, you may have for example, economics, or business, you may have a revenue function, you may have a cost function, you may have a profit function, you have all these different functions that are all true and they all apply, and we give them different letters. So revenue might be R of X, and then cost might be C of X, and then profit might be P of X. Well, I've given you a couple here. I've given you F of X, and I've given you G of X. Again, it's not f times x, it's not g times x, it's the name of the function, f of x. So let's start with f of -3. Why don't you go ahead and do that real quick and put your answer in the chat. I look forward to hearing what you got here. Be careful. Sophia first to get in the number 2. Haley 2. We see a number 2. More 2s. All right. A lot of 2s. Let's see. The machine, what it does is it changes. Ah, man. That was a twitch. Minus the input. So you're going to change the sign on the input. So you actually have a double negative here. So we end up getting 3 minus 1, which is 2. Very good. Very good on the number 2. All right, now let's go to the other side here. And I've got 2 problems for you to do right now. You're going to find g of 3 and g of -2. Now, before you do that, hang on. Wait. There's 2 places that you need to put those numbers, not just one. In this particular function, you have 2 places to put it. And I will warn you, some of you are going to miss the second one. So take your time there. Take your time there and get it right. Okay? I'm expecting to see 2 different answers on this one. So be careful. All right, I'm seeing 15 and 0. Did anyone get a different number? This is my poker face. Did anyone get a different number for the second one, g of negative 2? Anyone get a different number, g of negative 2? All right, let's check the first one. I'm still waiting to see here if anyone got a different number for the second one, but I'll go ahead and do the first one. The first one is going to be you square the input and then you multiply or add 2 times the input. So I'm going to be putting 3 in this time. So that would be 9 plus 6, which is 15. So yeah, everyone got 15 for the first one, which is awesome. All right, so a lot of you got 0 for the second one, so let's see if that's right. I am going to square the input and then add 2 times the input. And if I put negative 2 in there, I want you to notice that it's inside a parenthesis. And it needs to be, okay? That needs to be the way you do it. So that would be 4 minus 4, which is 0. 0 is the correct answer. I'll tell you what, some folks, believe it or not, are addicted to their calculator. And they very well might type negative 2 squared plus 2 times negative 2. So what happens is the calculator understands order of operations, and the second part is fine. You get negative 4. But your calculator will actually do negative 1 times 2 squared, which would be negative 4. So your calculator will say negative 8 if you type it in wrong. Okay, this was wrong. This was wrong because it really needed parentheses around here. When you don't put the parentheses there, the rules of math, it's called order of operations, say that the minus sign is not part of the base, and hopefully you remember me saying that. All right, so in the chat, do you remember me saying that before? That if you want to square the minus sign, it's got to be part inside a parenthesis. Yes or no? Haley says yes. Thank you for listening. Yes, Sierra. Okay, yes. They can be taught. Right? Quote from Aladdin, I think that, right? He can be taught. All right. That is function notation. I want to come back over here. One little thing, though, is I could throw you curveballs like this where you're actually putting an expression in where the x was. So we're going to put x plus 1 in that input location. And I want to point out that this x is actually completely different from this one. They're not the same variable, believe it or not. They actually are different because they're coming from different functions. So this would be the opposite of the input minus 1, and this time we are putting x plus 1 in there. And then of course we could simplify this. Negative x minus 1 is negative x minus 2. Negative x minus 2. All right, so that's a wee bit confusing, but once you realize that this x is simply your input, that's where you put things in. Normally we put numbers in, but we can even put expressions in. All right, so on the next one, once again, our machine, remember this machine is just hard-coded. It is the opposite of the input minus 1, and this time we are putting not a number in here, we're putting t squared. So the answer would be negative t squared minus 1. That minus sign's not part of the base, so we can actually write it just like that.